Example number 5. Jake and Jerry went on camping trip with their motorcycle. One day, Jerry left the camp on his motorcycle to go to the village. 10 minutes later, Jake decided to go too. If Jerry was traveling 30 miles per hour and Jake traveled 30 miles per hour, how long was it before Jake caught up with Jerry? Okay, so the the tricks here, before we discuss the tricks, we should visualize first the movement of our two campers, Jerry and Jake. So we have Jerry and Jake. So they went for camping for the motorcycle. One day they left the companies. So Jerry goes first, right? Then 10 minutes later, Jake followed. But if Jerry was traveling 30 miles per hour and Jake traveled 35 miles hours, so Jake is a bit faster, but he travels 10 minutes later. How long was it before Jake caught up with Jerry? Okay, so let's visualize the given. The trick here is the given 10 minutes. Before Jake catch up to Jerry, therefore our x here is equal. But again, like in our example number 2, I think, so they are going at the same direction. Therefore, we can say that our x is equal. So Jerry travels 30 miles per hour. How about Jake? Is 35. So of course, he moved faster. The problem is that is 10 minutes later. Okay, so in solving our problem, again, we already have our uh, constant definition. The rate are given, so we can formulate our equation from our TRD box. So set up our TRD box. So TRD box to simplify our solution in time rate distance problem. So we have Jerry and Jake. So let's start with their speed. We have for Jerry, we have 30 miles per hour. It is clear, that is 30. Our unit here is mile per hour. Therefore, our time here should be in hour also. In order for us to have the distance of mile, we cancel out hour. The remaining is mile. Okay? So how about for Jake? Jake travel faster compared to Jerry. So the 35 miles per hour. Okay? At that moment, they have an equal time when Jerry catch up with Jake. So therefore, our x here is equal, or our time. So since we let x be our time, the time when Jake catch up with Jerry, so we let x. Okay, so 10 minutes later, Jake followed. So it means that Jerry should have consumed the 10 minutes because he's ahead. Okay, before we write here 10, remember 10 minutes, our unit is in hour and the given is in minutes. Okay, so be careful in setting up your equation here. You cannot multiply right away at 10 to 30 because our unit here is in minutes and our unit should be in hour. So that is one of the tricks. Okay, so we need to convert our 10 minutes to hour. Okay, so doing that, if we have 10 minutes, convert it into hour, and every 60 minutes we have 1 hour. Okay, so we cancel out minute, so our unit will become 1 6. Okay, so 1 6 hour. Okay, so let's set up our equation. So our plus 10 here will become, this will become 1 over 6 if we convert it into minutes. Okay, so writing up our distance, that is 30 times the quantity of x plus 1 over 6, because we convert it into hour from minute. Okay, here that is 35x. Again, at that moment, they are what? They are equal in distance, right? So we can say this is our, so we can set up our equation right away. They have equal in distance. This is our 30x. The 30 times the quantity of x plus 1 6 is equal to 35x. Okay, so that is 30x. 30 times 1 over 6, that is 5, is equal, so 35x. Move, we move 30 to the other side, that will become 5x, therefore our x is 1 hour. The unit is in hour. That is the time will Jake catch up with Jerry. Okay, so there is no given time. There is no 10 a.m., 10 p.m. It only how long was it before Jake caught up with Jerry. So it will take Jake 1 hour to catch up with Jerry, because he's moving faster a bit than Jerry. Okay, so our answer is 1 hour. Let's move to our next example.